Hey everybody, my name is Wes Franklin. I'm a graduate student here in the OCS program. My committee members are Dr. Elizabeth Heiss, Dr. Alejandro Fierro-Cabo, and Dr. Jude Benavides. And my thesis project is an assessment of microplastic pollution in the fish, sediment, and water in resacas of the lower Rio Grande Valley, South Texas. So our research question here is, are there any microplastics in the resacas of South Texas? This is the first study to look at microplastic pollution in freshwater systems of South Texas besides the Rio Grande River. So there are many goals here. We wanted to gather baseline data and novel information. We wanted to discover what structures of microplastics were present, what chemical compositions, where these microplastics were found in the environment, and if there were differences between microplastics found in different species of fish, as well as in the sediment and water. So microplastics are defined as plastic pieces that are smaller than 5 millimeters in length. There's both primary and secondary microplastics. Primary are those that are produced to be very small, so things such as nurdles, and secondary microplastics aren't produced to be small. They are larger plastics that degrade into smaller plastics, as you can see in figure 1. Aquatic organisms ingest these microplastics and they have many negative effects on these organisms, including clogging the digestive tract, entangling the digestive tract, and leaching toxic chemicals into the muscle tissues. This can lead to biomagnification, which is a buildup of toxins and microplastics in higher trophic level organisms. So resacas are generally defined as former distributaries of the Rio Grande River. They used to function as seasonal water bodies. They would dry up in the dry season and become inundated with water in the rainy season. Due to human-induced impacts, they generally stay inundated year-round as we pump municipal water into them. Because of their location near urban areas and the fact that they're dislocated from the Rio Grande River now, it's worried that they're becoming sinks for pollution. We used 11 different resacas in and around the Brownsville area, including Resaca de la Guera, the Rancho Viejo resacas, Town Resaca, and Lozano Banco. We used 2 species of fish from these locations, Pterygoplithes disjunctivus, also known as sailfin catfish, and Dorsoma sepidinum, also known as gizzard shad. We also took water and sediment samples from these locations. So for our methodology, fish were captured using gill and cast nets. Once these fish were captured, they were taken to a boat and they were identified down to species. The native species were released, the invasive species were terminated. Besides Dorsoma sepidinum and Pterygoplithes disjunctivus, these were collected for our research. Water samples were acquired using a dip bottle, and our sediment samples were acquired using benthic cores and also shore shovels. Once these were captured, they were taken back to the lab, fish were dissected, and their digestive tract were surveyed for microplastics. The sediment samples and water samples were passed through a sieve system, and then these were checked for microplastics. Once microplastics were found, they were photographed and moved to a separate lab for Fourier transform infrared spectroscopy analysis, also known as FTIR. This works by shooting an infrared light at your plastic sample. Some of that light will be transmitted, some of that light will be absorbed. Based off what is transmitted and absorbed, it gives you a wavelength versus amplitude graph with a spectra on it. And that unknown spectra can be compared to other spectra to determine what your microplastic is. And this display right here in figure 4 shows that. We found that polyethylene, polyethylene terephthalate, and polypropylene are present in the resacas in and around Brownsville, Texas. We found that microplastics were found in 88% of all gizzard shad, 43% of all sailfin catfish, 91% of sediment samples, and 88% of water samples. Microfibers were the most prevalent, followed by chunks and other microplastics. There were no significant correlations between the size of the fish and the amount of microplastics found. Lozano Banco, which is located on the UTRGV Brownsville campus, was the most polluted with 59 plastics per pool, and Rancho Viejo, which is the most rural resaca, was the least polluted with only 10 microplastics per pool. In figure 5, you can see Lozano Banco is on the far left, and as you go to the right, you see the Town Resaca systems, the Resaca de la Guera systems, and then the Rancho Viejo system all the way on the far right. So in conclusion, plastics are most likely to be found in the water, followed by the sediment, gizzard shad, and lastly in sailfin catfish. Higher numbers of microplastics are most likely to be found in the sediment, followed by gizzard shad, water, and lastly in sailfin catfish. Microfibers are the most prevalent structure of microplastic found, and that is supported by many different studies. Our research shows that urban resacas are more polluted than rural resacas. And moving forward, we would like to find the sources of microplastic pollution in these resacas. Thank you. I hope you enjoyed this, and good luck to the rest of the presenters.